Section R.2, Integer Exponents, Scientific Notation, and the Order of Operations. Integer exponents. Okay, where the integers are 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on. We're going to do this in steps. So we start off with the natural numbers as exponents. And the natural numbers are 1, 2, 3, 4, 5, and so on. So definition. Let n be a natural number, and let a be any real number. Then a to the nth power means to multiply a by itself n times. Okay, it's shorthand notation for just repeated multiplication. So some terminology. Number 1, the entire expression, a to the n, is called an exponential expression. A is called the base. So the big number is the base. N is called the exponent or power. So the exponent or power is the small number. If n is equal to 2, then a to the second power is usually read as a squared. If n is equal to 3, then a to the third power is usually read as a cubed. Again, there's nothing wrong with reading it as a to the second power or a to the third power. Okay, we're looking at now in parentheses negative x to the nth power versus without the parentheses negative x to the nth power. The unfortunate thing is that they're read the same way, but they don't mean the same thing. The parentheses will in fact make all the difference. If you're going to be using your calculator to do this, if you see an expression in parentheses given to you as a problem, you should also use the parentheses on your calculator. So the first one, the one with parentheses, negative x to the nth power, does have negative x as its base. It does mean to multiply negative x by itself n times. You're going to have negative x times negative x times negative x, and so on. So you're going to have a total of n negative signs. There's actually this convention in mathematics that if you have a negative number, you do put it in parentheses with its minus sign, with the exception of the fact that it's the very first number in the problem. So I know that this minus sign really means that this number x is negative. Now what about the one without the parentheses? This one means find the opposite of x to the nth. So there's only one negative sign. So another way of looking at this is negative x to the nth power means negative 1 times x to the nth. We actually should read this as opposite of x to the nth power. This one will always be negative because you do x to the nth first and then change its sign. I'm assuming that there's no minus sign hidden inside of the number x. So some examples. Evaluate the following. Simplify your answers. Do not use mixed numbers or decimals in your answers. So first one, I have opposite of 3 squared. So this means negative 1 times 3 squared since there are no parentheses. So we first do 3 squared to get 9. So I have negative 1 times 9. So I get negative 9. Just to show you this on the calculator, okay, this is the TI-84 calculator that you can download for free on the internet. So if I do negative 3 x squared, I get negative 9. Notice no parentheses in the problem, no parentheses in the calculator. For number 2, in parentheses, negative 3 squared. Okay, this one does mean negative 3 times negative 3. And a negative times negative, I get a positive. So I get 9. Okay, again, if we were to do this on our calculator, open the parenthesis, negative 3, close parenthesis, x squared, 9. See, the calculator knows. Number 3 and 4. With parentheses, negative 6 squared, and number 4 without parentheses, opposite of 6 squared. Okay, number 3 does mean negative 6 times negative 6, which is positive 36. Okay, please don't get 12s on these. That's just entirely wrong. For number 4, it's negative 1 times 6 squared. So I do the 6 squared to get 36. So I have negative 1 times 36, I get negative 36. Number 5 and 6. Opposite of 2 cubed, negative 2 being cubed. Okay, number 5 does mean negative 1 times 2 cubed. Okay, 2 cubed is going to be 8. 2 times 2 times 2. So I have negative 1 times 8, I get negative 8. This one means negative 2 times negative 2 times negative 2. I have 3 minus signs, so the result will in fact be negative. I get the same answer. Notice, odd exponent. In 3 and 4, it was even exponent. Number 7, 14 to the first power is just 14. Okay, this example illustrates a very important concept. If you do not see an exponent, it is understood to be 1. Notice that's like denominators. If you don't see a denominator, it's understood to be 1. So we do not write exponents of 1. We do not write denominators of 1. Remember, that's not simplified. So never write an exponent of 1. It is not simplified. It will be marked wrong because, again, it is not simplified. Some notes about this. Okay, with an odd exponent, opposite of x to the nth, and negative x to the nth have the same value. Again, that's with an odd exponent. With an even exponent, negative x to the nth is positive, and opposite of x to the nth is negative. The parentheses makes the answer positive with an even exponent. Okay, keep in mind, even versus odd applies to even negative numbers. 0 is also even. Even simply means a multiple of 2. So 0 plus or minus 2 plus or minus 4 and so on, those are even numbers. Okay, it comes down to, is the exponent even? Remember, if it's an even exponent, the parentheses will make it positive. The zero exponent. Definition. Let a be any non-zero real number. Then a to the 0 power is 1. So by definition, anything to the 0 power except for 0 is 1. Because remember, the base cannot be 0. We'll see why that can't happen. There's a reason why the definition excludes 0 as a base. So again, the definition is saying that anything to the 0 power except for 0 is 1. Also keep in mind that 0 is an even number. Evaluate the following. Do not use mixed numbers or decimals in your answers. Our first one, 14 to the 0 power. Again, if you gave it to your calculator, let me just take this out again. If you take out a calculator, let me clear out this other stuff. Okay, 14, then raised to 0 power, we get 1. Okay, remember, anything to the 0 power except for 0 is 1. For number 2, pi to the 0. Remember, anything to the 0 power is 1. Number 3 and 4, negative 12 to the 0 power versus opposite of 12 to the 0 power. In number 3, the base really is negative 12. This is going to be 1. This one, the base is really 12. So I'm going to do negative 1 times 12 to the 0. I get negative 1. Okay, again, the parentheses made it positive. No parentheses, even exponent, it's going to be negative. Negative integers as exponents. Okay, again, this is going to come down to a definition. So definition, let n be a natural number, and let a be any non-zero number. Then we have the following. A to the negative n is 1 over a to the n. Notice the negative exponent on this side, positive exponent on the right side. And number 2, 1 over a to the negative n is a to the positive n. Again, negative exponent on this side, positive exponent on this side. This is telling you that the sign of the exponent changes as you move from numerator to denominator or denominator to numerator. Again, it's the sign of the exponent. There's nothing you can do about the sign of the base. Let's try some examples. So evaluate the following, which means point it out to a number. Do not use mixed number decimals in your answers. Simplify all answers. Simplify really means do all the number crunching, reduce your fractions, and don't write 2 fractions when 1 will do. Our first one, 4 to the minus 2 power. Okay, according to our definition, this is going to be 1 over 4 squared. Now again, don't leave it like this. You have to do the number crunching. 4 squared, I get 16. So 1 over 4 times 4, 1/16. If we gave this to the calculator just to show you, okay, again, let me clear that out. Okay, 4 raised to minus 2 power. Okay, we get this decimal. Remember, the directions said no mixed numbers or decimals. So to make a decimal go to a fraction on the TI-83 and 84, press the math button, and it's actually choice number 1, which says change the last calculated thing to a fraction. So you got to press enter twice, and notice you get 1/16, just like it said. Number 2, I have 1 over 5 to the minus 3. Again, according to our last definition, this is going to be 5 cubed, technically over 1, but we're not going to write it over 1, so it's just 5 cubed. So 5 times 5 times 5, we get 125. And again, if we gave this to the calculator, okay, 1 divided by 5 raised to minus 3 power, 125, just like we got by hand. So your calculator does know the rules. You just have to be able to enter it correctly into your calculator. Okay, going back to our problems. Number 3, negative 7 to the negative 2. Okay, again, notice, even exponent, no parentheses, the result is going to be negative. This is really negative 1 times 7 to the minus 2. Okay, the negative 1 stays in the numerator. The 7 to the minus 2 goes to the denominator as 7 squared. 7 squared is 49, so I get negative 1 over 49. And again, if we gave it to the calculator, negative 7 raised to negative 2 power. Okay, we get this awful looking decimal. So math, press enter twice, and there's negative 1 over 49. Number 4, in parentheses, negative 7 to the negative 2. Okay, this time the minus sign with the 7 will also go to the denominator. So this really means 1 over, and still in parentheses, negative 7 squared. Okay, negative 7 times negative 7, and I get 1 over 49. No minus sign. And again, if we gave it to our calculator, open parenthesis, negative 7, close parenthesis, raised to minus 2 power, then make it go to a fraction, math, enter, enter, 1 over 49, just like we got before. Number 5, 1 over negative 7 to the negative 2. Okay, my denominator is negative 1 times 7 to the negative 2. Okay, the negative 1 will stay downstairs. The 7 to the minus 2 will go to the numerator as 7 squared. 7 squared is 49. Okay, 49 over negative 1 is really just negative 49. And again, let me show one more time with the calculator. Oops, come on. 1 divided by negative 7 raised to negative 2 power, and we get negative 49, just like we did by hand. Okay, number 6, I have 1 over negative 7 minus 2. Okay, this becomes negative 7 squared. Okay, parentheses around the minus 7, still parentheses around the minus 7. This is really minus 7 times minus 7, which is positive 49. The calculator will give us the same thing. I'm not going to show that. Number 7, I have 2 to the minus 5. Okay, that becomes 1 over 2 to the 5th. Okay, 2 to the 5th, multiplying 2 by itself 5 times. So 2 times 2 is 4, 8, 16, 32. So 1 over 32. Number 8, I have 1 over 3 to the minus 4. Okay, according to our definition, that becomes 3 to the 4th. So I'm going to have 3 times 3 times 3 times 3. So let's see, 3 times 3 is 9, times 3 is 27, times 3 is 81. So I get 81. For number 9, I have 3 to the minus 2 over 2 to the minus 3. Now again, if you want to see the calculator in action, okay, let's see, let me clear out this other nonsense. I've got 3 raised to negative 2 power. Okay, I got to get out of the exponent because notice I'm still there, so we'll use our arrow keys. Divided by 2 raised to minus 3. Press enter. Okay, now I've got this decimal, so math, enter, enter, 8 ninths. Let's see if we can get it by hand. Okay, for this one we're going to do it in a couple of steps. First broke it apart as 2 fractions. 3 to the minus 2 over 1 times 1 over 2 to the minus 3. Okay. Now, the definition applies to both of these. This becomes 1 over 3 squared, and this one becomes 2 cubed over 1. I'll actually write it as 2 cubed over 1. Okay, now let me put it back together. 2 cubed over 3 squared. The bottom line is this. If it had a negative exponent, it moved. Anything with a negative exponent in the numerator goes to the denominator. Anything with a negative exponent in the denominator goes to the numerator. So that's all you have to do is focus on the things with the negative exponents. Move them from where they are. Okay, 2 cubed is 8, 3 squared is 9. So again, that's what we said. Anything with a negative exponent moves. If it has a negative exponent in the numerator, move it to the denominator. If it has a negative exponent in the denominator, then move it to the numerator. Okay, that way you don't have to write in these middle steps. Now, in terms of how many steps you have to write down, as many as you need in order to do the problem. So I get 8 ninths. Remember, that's what the calculator gave us. Number 10, I have 5 squared over 2 to the minus 3. Again, let's focus on the guys with the negative exponents. Okay, the 2 has a negative exponent. It's going to move. It's going to move to the numerator. The 5 has a positive exponent. It stays where it is. So I'm going to end up with a 1 in the denominator, so I'm not going to write it. So I'm going to have my movement here, 2 going to the numerator. So I've got 5 squared times 2 cubed. Now again, don't leave it like this. This is actually kind of a prelude to the order of operations of my dear Aunt Sally. Okay, you do the exponents first because it's, please excuse my dear Aunt Sally. So 5 squared is 25, 2 cubed is 8. And 25 times 8, I get 200. Again, if you gave it to the calculator, just to show you one more time, let me clear this out. 5 raised to the second. Now for 5, anything squared, you can use the squared key or the power key. Now I've got to get out of the exponent. Divided by 2 raised to minus 3 power. We get 200, just like we did by hand. Okay, number 11. I have 4 to the minus 2 over 3 cubed. Okay, again, look at the guy with the negative exponent. It's 4. So, 4 has a negative exponent, it will move to the denominator. The 3 has a positive exponent, this 3, so it stays where it is. So notice, I'm going to have a 1 in the numerator. You don't write 1s in the denominator, but you do have to write 1 in the numerator, otherwise you have empty space over a number. So I'm going to have 1 over 3 cubed times 4 squared. Okay, do the 3 cubed and the 4 squared. 27 times 16. And 27 times 16, we get 1 over 432. Again, the calculator will give you the same thing. I'm not going to show that. Number 12, I have 5 cubed over 7 squared. Again, focus on the things with negative exponents. We have no negative exponents, so nothing moves. Everything stays where it is. So I'm going to have 5 cubed over 7 squared, 125 over 49. And notice, the fraction is already simplified. I try to rig it so that the fraction will be simplified after you do all the algebra type stuff. I don't want you straining your brain on trying to simplify a fraction. Properties of exponents. Okay. The laws of exponents. Okay, there are only 3 laws of exponents. You need to know them as the laws of exponents. Okay, the first one, this is sometimes called the product rule. It's also called the first law of exponents. It says a to the m times a to the n is a to the m plus n. In words, when multiplying, add the exponents of like base. Okay, you have to have like base. Number 2, it's called the quotient rule. It says a to the m over a to the n is a to the m minus n. So when dividing, that's what a fraction is, it's division, subtract the exponents of like base. It is always the exponent in the numerator minus the exponent in the denominator. And notice the result is always written as a numerator. And the third law of exponents, it's called the power rule. It says a to the mn is equal to the a to the m times n. So for a power to a power, multiply the exponents. So a power to a power. Some consequences of the laws of exponents. It's actually consequences of the laws of exponents and the commutative and associative laws. Okay, number 1 says ab to the n is a to the n times b to the n. Okay, the exponent outside parentheses, the n, multiplies each exponent inside parentheses. These exponents are actually 1, and 1 times n is n. So even if these were other exponents, it's still exponent outside parentheses multiplies exponent inside parentheses. And the same thing applies if you have a quotient. So a over b all to the nth power is a to the n, b to the n. So exponent outside parentheses multiplying exponent inside parentheses applies to products and quotients. Again, those are consequences of the third law of exponents and the commutative and associative properties. The summary of the properties of the exponents. Okay, the first one, the product rule. A to the m times a to the n is a to the m plus n. The second one, the quotient rule. A to the m over n is equal to a to the m minus n. Of course, this assumes that a is not 0. You cannot have 0 in the denominator. Now, by the way, since we're here, looking at the second law of exponents, imagine m and n were equal, like a squared over a squared. Anything over itself is 1, but if we apply this law, we'd have a to the 0. That is the reason why anything to the 0 power, except for 0, is defined to be 1. And you can now see why a can't be 0. It puts a 0 in the denominator. Number 3, a to the m to the nth power, that's a to the m n. Those 3 are the laws of exponents. Product rule, quotient rule, power rule. They're also called first law, second law, third law. Number 4, a b to the n is a to the n, b to the n. Exponent outside parentheses multiplies exponents inside parentheses. And of course, his friend, a over b to the n is a to the n, b to the n. Again, provided b is not 0. You cannot have 0 in the denominator. Number 5, a to the negative n is 1 over a to the n, provided a is not 0. 1 over a to the n is equal to a to the n, again, provided a is not 0. And a to the 0 is equal to 1, provided a is not 0. These last 3, 5, 6, and 7, are all to make sure that the second law of exponents have no exceptions. That's the reason these definitions were made, to make sure the second law of exponents would have no exceptions. You need to learn these 7 properties about exponents. Again, there's just 7 of them, so take your time and learn them. Next, we've got to look at what does it mean to simplify an exponential expression. So simplifying exponential expressions. Now, of course, you will be using those 7 things as well as some number crunching. So simplifying exponential expressions. To simplify an exponential expression means a couple of things. It means, number 1, reduce all fractions. Don't leave 3/6, write a half. Do all of the number crunching that can be done. If you got 2 times 7, do 14. Don't leave 2 times 7. These first 2 are sometimes kind of hard to check because they involve numbers. The third one, only one occurrence of each letter in the final answer. So if your final answer you have an x sitting one place and an x sitting somewhere else, you're not quite done. Now, the simplifying exponential expressions assumes that we're doing all exponential expressions. Okay, so no addition and subtraction going on. Some examples. Simplify the following. No mixed numbers or decimals in your answers. Express all answers using positive exponents. Okay, notice this even excludes running anything to the 0 power, because remember, anything to the 0 power is actually 1. our first one. I have negative 4x to the minus 2, y to the fifth. Okay, if we check what's needed for our simplifying exponential expression, there is no number crunching to do. Our fractions are reduced. There is only one occurrence of each letter. The problem is I don't fit the last part of the directions. I have a negative exponent. Remember, anything with a negative exponent is going to move. The negative 4 is just a negative coefficient. There's nothing I can do about it. The x to the minus 2 will go to the denominator. So I have negative 4y to the fifth over x squared. Okay, in terms of the order, we like to write numbers first, and then we usually put the letters in alphabetical order. Usually, but not always. So now we have all positive exponents. Number 2, I have negative 6x to the third, y to the minus 7, over 5w to the minus 11, z. Now again, our fraction, negative 6/5 is reduced. There is only one occurrence of each letter. The problem is the negative exponent. The y is a negative exponent, and so does the w. So the y needs to go to the denominator, the w needs to go to the numerator. So we'll just let them switch places. So I've got negative 6x cubed w to the 11th over 5y to the 7th z. Okay. Again, write the numbers first, and the letters are usually written in alphabetical order, except sometimes for reasons known only to math people, we sometimes don't put w in alphabetical order. Number 3, okay, something kind of interesting. I have negative 5x cubed y to the minus 6 times 4x to the minus 7 y to the 14th. Okay, so I have to multiply the numbers, multiply the x's, and multiply the y's. I'm going to throw in a middle step, which quite frankly I'd be shocked if you ever did it. I'm putting the coefficients together. I'm putting the x's together. I'm putting the y's together. Remember, the fact that this is all multiplication and it's associative and commutative, that's what allows me to do it. Okay, in the next few examples are probably from this point on, I'll never do this again. So do multiply the coefficients. Negative 5 times 4, I get negative 20. Remember, for the x's and the y's, add the exponents. So 3 plus negative 7, negative 6 plus 14. Now again, please don't leave it like this. Okay, negative 5 times 4 gives you negative 20. For the x, 3 plus negative 7, I get negative 4. And for y, negative 6 plus 14, I get 8. Okay, notice I've saved the business of getting all positive exponents as my last step. I usually prefer to do that rather than trying to keep everything positive while I'm doing the problem. Okay, now I just have to make sure I have a positive exponent on everybody. So x moves to the denominator. Remember the negative 20? Its exponent is really 1. It's a negative coefficient. It doesn't have a negative exponent. So I'll have negative 20y to the 8th over x to the 4th. Number 4. I have a to the third, b to the minus 6 over c to the minus 7, d to the 4th times a to the minus 7, c to the 14th over b cubed d. Okay, having more letters just takes more time. It doesn't make it more difficult. It's actually having coefficients that can make it kind of nasty. So we're just going to take one letter at a time. So if I look at the a's, I'm going to do it alphabetically. Both a's are in the numerator. Because of how we multiply fractions, I'm going to have a to the third times a to the minus 7. So that means add the exponents. 3 plus negative 7, I get a to the negative 4. Okay, I'm going to leave it like that for the moment. Now I'm going to go to the next letter. Okay, for the b's, I've got b to the minus 6 over b cubed. That's the second law of exponents. Subtract the exponents. Remember, it's top exponent minus bottom exponent, and write it in the numerator. So negative 6 minus 3, I get b to the negative 9. Okay, so far I have these two guys in the numerator. Again, I'll worry about the negative exponents later. Okay, I'm up to the letter C. You notice the C's are like the B's. One in the numerator, one in the denominator. So c to the 14th over c to the minus 11, subtract the exponents. 14 minus negative 11, I get 25. Now please, be very careful when you're doing the basic arithmetic on the exponents. After all, it is just addition and subtraction. See, where am I now? I'm up to the D's. Okay, notice both D's are in the denominator. Because of how we multiply fractions, it stays in the denominator. And we will add the exponents. So downstairs is d to the 4th times d. Remember, that's an exponent of 1 because you don't see it. So 4 plus 1, I have d to the 5th in the denominator. Notice, if both letters are in the numerator or both letters are in the denominator, you will add the exponents, and it either stays in the numerator or stays in the denominator. If one of the letters is in the denominator and the other one is in the numerator, you'll subtract exponents. Again, remember, it's numerator exponent minus denominator exponent, and it's written in the numerator. The only time you ever start off in the denominator is if that's where both of the letters are to begin with. Okay, if I piece this all together, I'm going to have in the numerator a to the minus 4, b to the minus 9, c to the 25th, over d to the 5th. I now worry about getting positive exponents. The a and the b have negative exponents. The a and the b will go to the denominator. The c stays where it is. The d stays where it is. So I have c to the 25th over a to the 4th, b to the 9th, d to the 5th. And there's nothing else you can do to it. Number 5. I have a to the minus 8 b to the 4th over c squared d to the minus 7th, all to the minus 5. Okay, the first thing I want to do is I want to get rid of the exponent outside parentheses. This is where we use the power rule and the fourth property together. Remember, the exponent outside parentheses multiplies each exponent inside the parentheses. Okay, so I'm not going to move the letters, just taking one letter at a time. For the a, negative 8 times 5 gave me 40. For the b, 4 times minus 5 gave me negative 20. For the c, 2 times negative 5 gave me negative 10. And for the d, minus 7 times minus 5 gave me positive 35. Okay, now get positive exponents. The b and the c will need to move. So a to the 40, c to the 10th, over b to the 20, d to the 35. Number 6. Okay, it's like number 5, except I've thrown a number into the mix. Okay, remember, this exponent outside parentheses multiplies each exponent inside parentheses, including the exponent that's on the 2. Remember, the 2 has exponent of 1. So I'll have 2 to the minus 4, x to the minus 20, over y to the 8th. Okay, now let's get positive exponents. Notice, everything is going to go to the denominator, and we're going to write the number first. So I'm going to have a 1 in the numerator. Remember, you do have to write the 1 in the numerator, otherwise you just have empty space over something. So I have 1 over 2 to the 4th, x to the 20, y to the 8th. One last thing to do. I have to crunch out 2 to the 4th. Remember, that's going to be 2 times 2 times 2 times 2, which is 16. So 1 over 16, x to the 20, y to the 8th. Number 7, kind of a nasty looking problem. Got a to the minus 4, b squared, over c to the minus 3 to the 6th, all to the minus 5 power, times b to the 3rd, d to the minus 9, ac to the minus 4, all to the 6th power. Okay, the first thing I want to do is I want to get rid of the exponents that are outside parentheses. Remember, the exponents outside parentheses multiplies the exponents inside parentheses. It does not change where the letters are. So, how I got this one? Minus 4 times minus 5, 20. 2 times minus 5 is negative 10. Minus 3 times minus 5 is 15. 6 times minus 5 is negative 30. For the next one, b, 3 times 6, 18. For d, negative 9 times 6, negative 54. Remember, the exponent you don't see is 1. 1 times 6 is 6. Negative 4 times 6 is negative 24. Okay, now, taking one letter at a time. Okay, let's start with the a's. Okay, one in the top, one in the bottom. Answer goes in the numerator, and it's top exponent minus bottom. So, 20 minus 6. Again, we'll do the subtraction in the next step. See, we're at the b's. They're both in the numerator. The result will go in the numerator and add the exponents. So b to the negative 10 plus 18. The c's, they're both in the denominator. So my c will go in the denominator and add the exponents. 15 plus negative 24. The d's, one in the numerator, one in the denominator. I'm back to the numerator and subtract exponents. Remember, top minus bottom. So d to the negative 54 minus negative 30. Okay. Now we start doing some number crunching on the exponents. Remember, it's just basic addition, subtraction. So this is going to be 14 for a, b looks like 8, d looks like it's going to be negative 24, and c is going to be negative 9. Now we want to get all positive exponents. The a and the b are okay. The d and the c need to switch places. So I'm going to have a to the 14th, b to the 8th, c to the 9th, all over d to the 24. Again, just take your time, one letter at a time, no big deal. Having more letters doesn't make it more difficult, it just makes it a little more time consuming. It's actually having numbers that can make it horrible. Okay, scientific notation. Okay, as the name implies, it really is for science classes, but it is an application of exponents, so that's why we're stuck teaching it. So the scientific notation is used to write numbers that are very large or very small in absolute value. Usually that means they have a bunch of zeros with them. So the format for scientific notation is this. Capital N times 10 raised to the little n. Okay, some people read it as n by 10 to the nth, reading this as though it were like lumber, a 2 by 4. Now, where? There are certain restrictions. Capital N is equal to a decimal number with exactly one non-zero digit to the left of the decimal point. So there has to be one non-zero digit to the left of the decimal point. Any other digits are to the right of the decimal point. Little n is an integer that counts how many places the decimal point in capital N must be moved to restore the number to its original value. Okay, the numbers that we normally write, like 155, that's usually called standard form or normal form or decimal form. A number that is not in standard notation, like 25,908.25, is said to be in decimal form, standard form, or normal form. In standard form, to the left of the decimal point, so these guys over here, we normally put a comma after groups of 3 digits. Okay, that's what we do. Put a comma. Please do not put a space. Put a comma. And where we have a decimal point, please use a decimal point. Do not put a comma. So we are using a decimal point and comma. Okay, no spaces. This is one of the few times we don't actually put a space after a comma. So now, again, we normally put a comma after groups of 3 digits beginning from the decimal point and going to the left. These groups of 3 digits are called periods. So here's a period, here starts another period. Okay, and we normally say separate periods by commas. That's just how it's phrased, separate periods by commas. When you're doing your homework or doing the test, be aware, do the directions say to separate periods by commas. It's actually easier to read the number if you do separate periods by commas. And again, please use a period, not a space, to separate your periods. If you separate them with a space, it will be marked wrong. If you use a comma where a decimal point is supposed to be used, it will be marked wrong. So some examples. Convert each of the following to standard form. Separate periods by commas. Okay, for us, or for me, all I really want you to be able to do is convert from standard form to scientific notation. So here's our first one, 4.766 times 10 to the 8th. Okay. This exponent of 8 means move the decimal point 8 places to the right. Okay, so we're going to take this decimal point and move it 8 places to the right. Now notice I already have 1, 2, 3 digits to the right. So that means I'm going to need 8 minus 3 or 5 zeros. So I'm going to write 4766 and then follow it with 5 zeros. Okay, do I have 5? 1, 2, 3, 4, 5. Yes, now put your commas. So a comma here and a comma here. So I've got 476,600,000. For number 2, I have negative 4.52 times 10 to the 14th. Now please don't lose this minus sign right here. Okay, the 14 says move the decimal point 14 places to the right. Okay, I already have 2 showing, 2 digits showing. So I'm going to need 14 minus some, I'm going to need 12 zeros. So put negative 4.52 and then follow it with 12 zeros. Okay, hopefully that is 12. Now put your commas. Okay, notice it's easier to insert the commas after you put down all the zeros you need. So in absolute value, this is a rather large number. The usual thing that goes wrong is students lose that minus sign, which is kind of a tragedy that you missed the problem just because of that one slight error. Number 3, I have negative 1.053 times 10 to the negative 7. The minus sign on the exponent says move that decimal point 7 places to the left. Okay, remember, minus is left. Now don't lose that minus sign. Remember, there's always one non-zero digit there. So it's kind of like if you ignore that minus sign, you need one less than that exponent, that many zeros. So I'm going to move that 7 places to the left. So again, there's always one digit. Again, there's always one digit in scientific notation that's already to the left. So I'm going to need 6 zeros after that, or to the left of that 1. Again, don't lose that minus sign. So let's see, do I have my zeros? 1, 2, 3, 4, 5, 6. Okay, so now again, on the right-hand side, don't separate periods by commas. There's no such thing as periods on the right side of the decimal point. It's only on the left. Now this 0 right here that's to the left of the decimal point, that's sometimes called a leading 0. It's your choice if you want to put it. Okay, you can leave off that 0. I always like to put it. It's these zeros right here that you truly need, those 6 zeros. Number 4, I have 3.684 times 10 to the minus 4. Okay, the minus 4 says go 3 places to the left. Now again, remember, there's always one place to the left. So I need 4 minus 1 or 3 zeros. Okay, I got to put 3 zeros in front of that 3. So 0.123 zeros, 3684. Okay, please don't round, don't throw away any of the digits that are already there. Again, that leading 0 you don't need, but you do need those 3. Okay, let's go the other way. Write each number in scientific notation. So you have to think backwards now. Okay, you have to kind of think backwards on this. So I have this rather large number. See, what is that? That's thousands, millions, billions. That's 45 trillion. So the decimal point is here. Remember, if you don't see a decimal point, it's to the right of that last number. So you have to move it to be here. So how many places are we moving it? 3, 6, 3, 6, 9, 12, 13. I'm moving it 13. But notice, to restore the number back, I got to go to the right. So it's going to be 4.5 for my n, my capital N is 4.5, and to count the number of digits, again, 3, 6, 9, 12, 13, so my little n is 13. So I have 4.5 times 10 to the 13. For number 2, again, don't lose that minus sign. I have what? Negative 5,621,000,000. So my capital N is negative 5.621. Okay, and it's those digits you see there now. To get my little n, 3, 6, 9, because I want it to be right there. Remember, I want one digit, only one digit to the left of the decimal point. So my little n is 9, so I have negative 5.621 times 10 to the 9th. Usually what goes wrong is students are off by 1 in their exponent because of the issues with counting. Number 3, I have negative 0.00000045. Now don't lose that minus sign. That's going to be my capital N. My capital N is negative 4.5, so I want it to be here. Now, my exponent is going to be negative, so we count the zeros and just add 1. Now, remember, you don't have to count the leading zero. I got 1, 2, 3, 4, 5. Add 1 to that, and I get negative 6. Okay, so negative 4.5 times 10 to the negative 6. Remember, the exponent has to be negative because the number is less than 1 in absolute value. Number 4, 0.00002577. My capital N is 2.577. Okay, let me count the zeros that matter. 1, 2, 3. Add 1 to that, I get 4. So little n is negative 4. So 2.577 times 10 to the negative 4. Again, remember, if the number is less than 1 in absolute values, your exponent will be negative. You just count the zeros that matter. Don't count the leading zero. Count the zeros that matter. Add 1 to it. Okay, the order of operations. Now again, if you're using all numbers, I really don't know why you wouldn't use your calculator to do the number crunching. So it's kind of like this is your last resort. Your calculator batteries have died or something. So symbols of grouping. Definition. When performing arithmetic operations, parentheses, brackets, and braces are called symbols of grouping or grouping symbols. The numerator and denominator of a fraction have what are called implied symbols of grouping around them. You have to remember that if you give an operation to your calculator, that you may not see the parentheses in your problem, but you have to put them for the numerator and the denominator. Anytime a numerator or a denominator has any sort of operation in it, multiplication, addition, subtraction, whatever, you need parentheses around them. Okay, when giving a calculation to the TI-83 or 84 family of calculators, you must remember to enclose the entire numerator and the entire denominator in their own set of parentheses. This is if they have their own operations. If it's just a single number, then you're fine. It really matters. It can change the outcome. It can drastically change the outcome. So, the order of operations. Okay, all math operations are done in the following order as the problem is read from left to right. Remember, left to right is how we read. So first, evaluate all expressions inside parentheses. For parentheses inside of parentheses, called nested parentheses, start from the innermost and work your way out. For the please excuse my dear Aunt Sally, this is the P part, right? Parentheses. Okay, then remember, please excuse my dear Aunt Sally, E, exponents. Second, evaluate all exponential expressions. Third, evaluate all multiplications and divisions as you encounter them in going from left to right. Okay, so multiplication and division have equal priority. So this means if you see division before multiplication, you will do the division first. If you see multiplication before division, you will do the multiplication first. Okay, so they have equal priority. Your calculator will know this. Okay, it will change the outcome sometimes, but not all of the time, if you switch the order. Now, just like multiplication and division have equal priority, so do addition and subtraction. So fourth, evaluate all additions and subtractions as you encounter them and going from left to right. So if you see subtraction before addition, you'll do subtraction first. If you see addition before subtraction, you will do the addition first. So again, addition and subtraction have equal priority. Multiplication and division have equal priority. If you mix up the addition and subtraction, as long as you keep track of your minus signs, you're probably okay. Now again, your calculator does know the rules and order of operations. So if you can give the problem to your calculator correctly, your calculator will give you a correct result. So be careful with the parentheses keys. The usual thing that goes wrong is students forget to enclose entire numerators and denominators in parentheses. Let's try some examples. Perform the indicated operations and simplify. Now sometimes it'll just say simplify or evaluate. Remember, when it's all numbers, simplify and evaluate do in fact mean the same thing. Our first one, 18 divided by 6 times 3. Okay, if we give this to our calculator, let me take out our calculator. I guess we got to turn it back on. Okay, let me clear all this stuff out. Okay, so I've got 18 divided by 6 times 3. I get 9. Okay, I don't know why it's telling me this awful thing. Okay, let me see what we get when we do it by hand. Okay, if we do it by hand, okay, there aren't any parentheses. So remember, multiplication and division have equal priority. I see 18 divided by 6 first. It gets done first. 18 divided by 6 is 3. So I have 3 times 3. Notice I have nothing left to do except multiplication. So I get 9, just like the calculator gave me. Number 2, I've thrown smoothly around 6 times 3. So it gets done first. If we give it to our calculator, okay, let me clear that out. So 18 divided by, open parenthesis, 6 times 3, close parentheses, I get 1. Okay, by hand, 6 times 3 is done first, so I have 18 divided by 18, which is 1, just like the calculator said. Number 3, 4 squared times 12 divided by 6. Again, if we give it to the calculator, okay, 4 squared times 12 divided by 6. Calculator says 32. Okay, we do the 4 squared first. Remember, please excuse my dear Aunt Sally. So I get 16. So now I have 16 times 12 divided by 6. As I go from left to right, I see the multiplication. So 16 times 12, I get 192. And now 192 divided by 6, 32, just like the calculator said. Okay, number 4, 6 squared minus 7 cubed. Okay, I have the two exponents. They are done first. Okay, 6 squared is 36, and 7 cubed gives me 343. Okay, 36 minus 343, negative 307. Now please, don't lose it on basic addition and subtraction. Number 5, I have 8 minus 12 times 16 minus 3. Okay, these are not nested parentheses. They're kind of equal priority, so we do what's inside the parentheses first at the same time. Okay, 8 minus 12 gives me negative 4, and 16 minus 3 gives me 13. So negative 4 times 13, I get negative 52. Again, if you want to see it on the calculator, let's see me go back. If you want to see it on the calculator, clear that out. I have 8 minus 12, close, open, 16 minus 3, close. Notice I entered it exactly like it looks. I didn't even put the times sign there. And I get negative 52, just like we got by hand. Okay, now number 6. This is a rather hideous one. So if we give this to our calculators, we can see what we're shooting for here. So let me clear that out. Okay, the brackets, we're going to use the parentheses keys. Okay, so all the symbols of grouping on the calculator are done with parentheses. Do not use the brackets and braces keys on the calculator. They don't mean what you think they mean. So 3 minus 6, open. 9 minus 4, open. 2 minus 8, close, close. I'm getting 1188. Whoops, something's wrong. Ah, I put 36 here instead of what the problem said. Clear that out. 3 minus 6. Do I have it right now? Yes. Open parenthesis. 9 minus 4. Open parenthesis. 2 minus 8. Close, close. Negative 195. Okay, let's see what we get by hand. Okay, I do actually have nested parentheses. So if I start just doing one thing at a time, I got to do 2 minus 8 first. So the 2 minus 8 is done first. Everything else stays where it is. So 2 minus 8, I get negative 6. Okay. As I work my way out from those parentheses, I encounter this multiplication. So I got to do minus 4 times negative 6. You can think of this as subtract 4 times negative 6 or minus 4 times negative 6. Either way, you're going to get a plus, because minus minus is plus. So I'm doing the 4 times negative 6. Everything else stays the same. Now please don't lose this other stuff. Again, minus times minus is plus. If you didn't think of that as minus 4, you'd have 9 minus negative 24, which becomes plus, minus minus. Okay, I have no choice but to do 9 plus 24. That's the next operation inside the brackets. That's going to give me 33. As I work my way outside the brackets, I've got multiplication. So I've got to do 6 times 33. So I have 3 minus 198, which gives me negative 195, which is that what the calculator said? Yep. The usual thing that goes wrong is students will do 3 minus 6 because it looks so tempting. Notice we never did do 3 minus 6. And let's try one more. Okay, again, if I give this one to the calculator, okay, let me clear that out. 8 minus 3, open, 2 plus 6, open, 3 minus 12, close, close. I'm getting 164. Okay, let's see what we get by hand. Okay, I have parentheses inside the brackets, so that is where we'll start. 3 minus 12. Everything else stays the same. 3 minus 12, I get negative 9. So I'm going to have 8 minus 3 times 2 plus 6 times negative 9. Okay, as I come outside the parentheses, I have to do this multiplication. Everything else stays the same. So 6 times negative 9 is negative 54. I'm still inside the brackets. I have to do 2 minus 54. So 8 minus 3 times negative 52. Okay, now I'm going to think of this as a negative times a negative, so I'll get a plus. And 3 times 52, I get 156. So I'm going to have 8 plus 156, which gives me 164. The same result I got with the calculator. That's the end of section R.2.